created by Mindsticks Foundation Trust.
Welcome, students. Today's explainer covers 5 key topics. We'll start with visualizing statistical data, move on to an introduction to histograms, learn about making classes continuous, and finally look at drawing frequency polygons, both with and without histograms.
Let's dive straight into part 1, visualizing statistical data. We're all quite familiar with central tendencies like the mean, the median, and the mode. But imagine trying to judge the performance of different standard 10 divisions just by looking at a massive table of marks. Sure, the mean helps, but let's be honest, numbers alone do not quickly reveal the complete story. A plain table actually hides the broader trends of the data. This is where pictorial representation changes everything. Just notice how looking at these pie charts of the rupees distribution helps us grasp the annual budget almost instantly? A simple, well-drawn chart makes complex data understandable to anyone, revealing important trends at a single glance.
Moving right along to part 2, introduction to histograms.
Now, observe this data showing the net asset value of various mutual funds. If you look closely at the classes, the first is 8 to 9, and the next is 10 to 11, you'll immediately spot a glaring problem. The classes jump. They are not continuous. And here is the rule. We simply cannot draw a unified, proper histogram when there are gaps in our data. So, how do we fix this? That brings us to part 3, making classes continuous. To close that 1-unit gap between 9 and 10, we simply divide the gap by 2, giving us 0.5. By subtracting 0.5 from the lower limit and adding 0.5 to the upper limit, we create continuous extended classes. Notice how the new classes flow perfectly now. One goes from 7.5 to 9.5, and the very next one starts exactly at 9.5.
Let's break down the exact method for drawing our histogram. Step 1. If your given classes are not continuous, you must make them continuous. Step 2. Show these extended classes on the x-axis using a proper scale. Step 3, show the frequencies on the y-axis, again with a proper scale. And finally, step 4, taking each class as the base, draw rectangles with heights that are exactly proportional to their frequencies.
Also, take a good look at the crink mark on the x-axis, that small, jagged, broken line. This is a very clever symbol. It indicates that there are absolutely no observations between the origin and our first class. Using a crink mark saves valuable space on our graph paper when our data does not start at 0. And here we see our final completed histogram. We have our crink mark starting the x-axis, followed by our continuous classes starting smoothly from 7.5. Notice how each continuous class forms the solid connected base of a rectangle. There are absolutely no gaps between the bars, which beautifully represents the continuity of our mutual fund data. Now let's step it up a notch in part 4, drawing frequency polygons. To draw a frequency polygon right over a histogram, we follow a simple logical sequence. First, we find and mark the exact midpoint of the top upper side of each rectangle. Second, we must anchor our line to the x-axis so the figure becomes completely closed. We do this by assuming imaginary zero-height rectangles just before the first class and just after the last class, marking their midpoints right on the x-axis. Finally, we join all these midpoints in order using straight line segments. Observe this carefully. You can clearly see the points plotted right at the top center of each rectangular bar. By joining all these midpoints in order by straight line segments and anchoring them firmly to the x-axis at both ends, a closed figure is beautifully formed. This closed shape is exactly what we call a frequency polygon. It smooths out the bars to show you the true shape of the data's distribution. But what if we want to skip drawing the bars entirely? That is part 5, polygons without histograms. We can absolutely do that using a mathematical shortcut. We simply prepare a table of coordinates. For our x-coordinate, we calculate the class mark, which is just the exact middle value of the continuous class. For our y-coordinate, we take the frequency. For instance, for the continuous class 7.5 to 9.5, the middle class mark is 8.5. Since the frequency is 20, our coordinate point to plot directly on the graph becomes 8.5, 20. By plotting just these specific coordinate points on our graph paper and connecting them with a ruler, we obtain a perfect, standalone frequency polygon. Notice how clean and professional it looks. We achieved the exact same trend line, anchored nicely to the x-axis at class marks 6.5 and 18.5, entirely without the visual clutter of the histogram bars. The true power of this visual tool is instant, immediate analysis. Let me ask you, without looking at any complex data tables, can you tell where the data peaks? Because the frequency polygon represents frequency as height on the y-axis, the absolute highest point on the graph instantly shows us the class with the maximum frequency. It's a highly efficient way to read and interpret data. Look at this final polygon charting students' marks and visually spot the highest peak. You can immediately see the maximum frequency is 60 students at the coordinate 65, 60. Think about how incredibly fast you found that answer visually. Now imagine applying this not just to a classroom, but to millions of data points in global finance or healthcare. What hidden stories could you uncover if you just drew the right polygon? Keep practicing, students, and keep visualizing your data.